So what happens when you subject motor oil to extreme conditions? I'm Gale Banks, and I'm at AMSOIL in Superior, Wisconsin. Let's find out. It's time for Speed School. Over the last 3 episodes, I learned how motor oil is manufactured, the chemistry behind it, and how to properly test lubricants. Today, we're putting oil to the test on the engine dyno. It's the final day of my lubrication education. I'm with Dan Peterson. We're here at the AMSOIL Mechanical Lab Dyno Cell 1, which is big enough to have a party in. Band, dance floor, the whole thing. I wish we had dyno cells this big at Banks. I understand you stabilize the temperature and the humidity of the air entering the engine. Mm-hmm. Of course, you guys get some
extreme temperatures.
Yes, yeah.
It's a challenge.
The NASCAR guys have started doing that, where they have very, very closely controlled atmospheric conditions, if you will, in the dyno cell. That way they can find minute changes, find a half a horsepower, that type of thing.
Yeah.
That's expensive to condition that air.
It is. Yeah.
And I understand you guys are doing that here.
Yeah, we're controlling to a dew point for the humidity of the air, and it's done for a specific reason. We're not looking for a half horsepower or 1 horsepower here and there. What we're looking at is deposit formation on engines with specific chemistries that we run. And what we found is by controlling the humidity of the air, and then of course the flow rates, of the air and the temperatures, we're able to replicate the conditions much better. So when we take a look at a specific engine oil formulation, it'll produce X amount of deposits, and then when we run another engine oil formulation, it'll run Y number of deposits. Pretty repeatable. Without the humidity control of the air and dew point control, we would be struggling. You would think 40 below, in the winter, and then trying to replicate that same test here where it's almost 90 degrees in Superior in June, which doesn't happen much.
What can you tell us about the dyno engine and the setup you have in here?
This setup here is specifically for durability testing. It's a GM small block engine, about 350 cubic inch. We set it up and outfitted it with instruments so that we can do what we want to do in here. The test procedure is where we get into the intricacies of this. So it's a pretty basic crate engine that we get. And each time that we run this test, this 50-hour test, we're basically changing all the sliding surfaces out. So pistons, rings, cams, all our major bearings, all are getting changed out because they're critical wear parts that we're taking a look at when we're looking at this cycle. So this cycle is for race oils. So it's specifically put together for race oils. So we're kind of the race company that does high-end synthetic lubricants, and this is our high-end race oil product here. So we're stressing the oil to the max. So what we're trying to do is get away from just focusing on separation of surfaces through the thickness of the oil to the contribution of the chemical additive packages that go into the actual motor oil. So when you start to lose the base oil surface thickness, then that's when the chemistry kicks in, and we have specific chemistries that we're taking a look at. When surfaces get close to touching, then there's little asperities that can micro weld.
Absolutely.
And the chemistry coats those surfaces.
Temperature and oil pressure, what do you do there?
So we built the cycle so that we're going to get into very low oil pressure conditions that simulate, say, coming out of a turn on a dirt track, where you're on the brake and then you crank on the throttle, so you're bringing everything back up coming out of a curve.
So
and
you're hitting peak cylinder pressure off the turn.
Right.
Torque peak and peak cylinder pressure usually happen at the same time, RPM wise. So you're really that severe.
Yeah. And your oil pressures really get down there, because gravity's against you a little bit when you're in a turn. And we get it to the point, we take it down to the point we're still getting oil up to the critical areas, but in a much reduced fashion, so that we are stressing the chemistry of the oil on purpose. All right, Gale, what we're going to see now, what I want to show you, is an example of this test. So we're going to fire up this Chevy small block 350 engine, and we're going to take it through the dyno cycle. It's going to be loud. It's tough conditions, but I think you'll enjoy it.
I like loud. So let's do it.
Let's do it.
Yeah. So we're in the warm-up cycle. It's been coal-fired, turning about 2,500 RPM light load. What can you tell me about what we're about to see here, Dan?
Well, we're treating it like a race engine. We're making sure that we warm it up.
Yes.
We're bringing the oil up to temperature. We're getting things starting to expand and getting it ready for that first dyno pull.
Gotcha. It's automated. When it hits 200,
we wrote the program such that we don't have to have an operator here the entire time.
Yes.
So, and it takes the variability out of the cycle. So when we hit a certain oil temperature, then we're all ready to go. It hits the next stage of the program, and then we replicate this test over 50 hours then, basically with no interface. It really is a severe cycle test, and that's what we do at AMSOIL. You know, we take things to the extremes. So we don't build for minimum specifications.
Yes.
That's for the other guys. We're building everything for severe service because we're solving problems in the industry. So whether it's in a race engine, in a wind turbine, in a 2-cycle small engine that's running really lean, we're solving the problems that other people can't solve. And this whole mechanical lab and tests like this that we design that are built to do things that you would never see, you know, out in the real world, allows us to find out what the breaking points are for oil, and then we fix them.
we hit 200 degrees.
Now we're moving.
Or close to it. Here it comes. So now
we're into
going to
the
have
cycle.
A real look
Yeah.
at this. Yeah.
So what we're taking a look at here, the total test is 50 hours.
Yeah.
And the test consists of 2 basic horsepower pulls, like a dyno pull, every minute over the 50 hours. So we do 2 basically from idle to wide open throttle,
Yes.
heavy load, typical dyno pull. And then we've got some throttle whips built into this test also,
Yes.
where we're trying to stress the chemistry in a low oil pressure situation. So we're down at idle, not below 800 RPM, but we're down
Yes.
at idle. So we've got pretty low oil pressure and low flow of oil, and that's the time that the additive chemistry really kicks in, and that's one of the things that we're testing. So we're trying to test at both ends of the extreme. Really good oil flow up to moving parts, separated surfaces, down to conditions where you got low RPM and some pretty good load at times, and you're stressing the chemistry then. So both ends of the spectrum.
Is this a 30-second series that repeats every 30 seconds? Twice a minute?
Basically, yeah, twice a minute. So
Yeah.
it's 2 times during a 1-minute period.
Got it.
Replicates that cycle.
So we're pulling down into the torque now.
Yep. So you can hear the heavy load on the engine.
Yep.
RPM's going down. So this is the back loading part of it.
Yep.
And now we're bringing it back up.
Just watching the horsepower here.
Yep.
These are close to 300 horsepower each pull there. Now we're pulling it down. Torques.
Yeah, this is rough on the engine right here. High torque, low RPM.
Do we have throttle position on screen? There it is.
Oh, okay.
Okay, so looking at TPS. Coming up to 90% throttle, going for 100% and lugging it down to 100%. So we're peaking out the torque. Don't worry, guys. I'm not going to make you sit through 50 hours of looking through the glass here and looking at this screen.
Okay, Gail, here's the cycle that we were just taking a look at in the dyno room.
Exactly.
on a graph.
Yes.
And what we've got here is a pretty severe cycle.
So this is the program.
This is the actual program that we wrote that simulates all of the conditions that stress the oil, like in a racing application.
Got it. This is 1 minute out of 50 hours.
Yeah, so we're going 24 up to 84 seconds.
Seconds, yeah.
So basically that's 60 seconds, so 1 minute. So we got 2 dyno pulls within 1 minute, and then this test goes on and on and on to the point that we've got actually 6,000 dyno pulls within the whole test.
Yes.
And we repeat this cycle, 3,000 times.
Here we've got throttle position. So we're starting out at maybe 40%, up to 100% throttle, cut back to idle, 0 throttle position. And then we cycle it through, blip, 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 to damn near 100 on these whips, back down to 0, and here comes your dyno pull all the way to 100% and back into the whips again. The oil pressure is over 50 here at the beginning, drops down into the high 40s, up over 50 again, and here it drops, and I saw on the instrumentation about 19 pounds of oil pressure in these whips. So you get to the bottom of the oil pressure, which is right there. Okay, so looking at engine speed, which is the blue trace, here comes the engine speed, and you're right, as you increase the engine speed, the oil pressure is still falling. So you're going to full speed here, and the oil pressure is way behind the increase in engine speed. So you've got this surface speed on the bearings going up, you're zeroing out the oil film, and you're going to rest of the oil package, especially the ZDDP.
And it's not treating that oil very well, but we're doing that on purpose because racers don't treat oil very well.
Basically, you're hitting peak oil pressure after the peak RPM occurred. And you're doing it, this is brutal, and you're doing it repeatedly. And now here we go back into a full dyno pull and 2 more whips. So there's 5 whips and 2 dyno pulls in 1 minute. This is pretty brutal.
Not the typical cycle that your daily driver goes through.
Yeah, and to do this for 50 hours, most guys' dyno pulls last about from here to here. You see all the guys, I call it kiddie dyno. They don't know the life of the engine because they never stress it fully. You'll see these dyno pulls that are 3, 4, 5 seconds. Nothing gets heat soaked, nothing gets normalized, and you don't cook it. So compare 5 seconds to 50 hours. It's a whole different thing. I want to see what the engine looks like.
Well, Gail, we're in luck because we had the guys tear apart the engine, and that's where we're going next.
Okay, beautiful. Okay, we got us a bare block here.
Yeah, this is our mechanical lab where we do tear down. So it's
Yes.
a tear down area. This is Mark Nyholm. He's the manager of our mechanical lab, and he's done us a service of tearing down that engine that we just abused for a while and saw
Got
the
it.
cycle on.
Good to see you, Mark.
You too.
What are you after here?
Welcome to looking at this engine after we tore it down a couple hours ago.
Yes.
With every product development project that we start, we always start with new components. But as you know, new components have variation from every factory that they come from.
Yes.
So when we build them into an engine, we must measure what the starting condition is. That is our baseline.
Got it.
And then we run our tests, and then we measure the differences, which we would attribute as wear in the end. So we look at bore diameters in the block. We look at clearances and bearings to your rods to your crank. We look at the bearings, the crank bearings to the crank. We're looking at rings into the liner. We're looking at valves. We look at valve guides. We look at cam profile. We're measuring lifters. We look at push rods to rocker arms. Every movable component of this engine we measure.
Yes.
and then we compare back to our original measurements. And that
which
difference
are your
is
baseline.
and that's our baseline.
Yeah.
And the difference between those two is what we attribute as wear.
Gotcha.
We take those measurements and we take that conversation round circle with the chemical lab that you just had the conversation
Yes.
with, and that's product development. It can be iterative because we test individual chemicals. We want to know the changes that are measured from an individual change, so we're not measuring variation, but the change from that individual chemistry.
So do you look at combustion chamber deposits, tops of the pistons, things of that nature as well?
Absolutely. We're looking at wear, we're looking at deposit formation. We want to make sure that we don't form deposits in the ring lands to your rings so they don't have stuck rings.
Yes.
Absolutely.
So valves, valve guides and all, huh?
We look at valves, we look at valve guides. There's not a single component, movable component in this engine that we're not looking at
Got
and
it.
measuring.
Yes.
You know, not just looking at, but measuring. You have to put a number to it.
Yes. It's way beyond anything I expected to see coming here. This is, I'm sold. I think I know what engine oil we're going to be running in the Banks turnkey diesel program. And I hope you guys learned something. I know I did. Anybody up for a beer?
I'm in.
Oh, I'm in.
Oh my God. This is my wife's worst nightmare on a Sunday morning. Mowers and leaf blowers. Woo! Shut that door, for God's sakes. Shut the door.